for golf event. So we are having this kind of a golf event, but because there are forests, so this means we need to cut off trees for the golf event. Yeah. So let's just try to simulate the problem. So we're gonna cut off the trees in increasing order. So for example, we're gonna cut off the trees in like 1, 2, 3, 4, 5, 6, and 7. Yeah. But we're gonna start from the position with 0 and 0 because this is a 2D coordinate system. So basically, yeah, it's a 2D grid. So this means we're gonna start from the top left corner. So this is what we are giving, and even yeah, but at the top left corner, yeah, let's just check the problem. So it can have some numbers. If it is a 0, so this means this cell cannot be walked through. So if this is a 0, this means this cell basically cannot be walked through. It means some obstacles. And if it is 1, represent an empty cell that can be walked through. So for this one, this just means an empty cell. So for this one, yeah, and a number greater than 1 represents a tree. So for example, this is 2, 3, 4, 5, 6, 7. It is greater than 1 and represented by a tree. So this means we can cut off 3, 2, 3, 4, 5, 6, and 7. And for this example, we can cut off like 2 and 3. Yeah, but we want to cut off 5 because there are obstacles of those zeros. So this means we cannot cut off them. So this is why we're gonna return a -1. And our return is not about how many trees. Our return is about how many steps we're gonna walk through. Yeah. So for this example, it is just 6 steps, but for other example, it may be more steps. Yeah. So, yeah, let me just make a drawing, maybe find a better example to explain what kind of method we're gonna use to solve the problem. Yeah. So in the black areas, it's going to be 0. So for example, if I have some trees, so for example, this is a 2, and this is a 3, and this is a 4, and here going to be 0. Yeah, let me make it with no 0, maybe. Yeah, let's just make it yeah, make it 1 maybe. Yeah, because 1 is just empty spaces. Let's just make it 1. So how many steps are we gonna need to cut off all those trees? So we're gonna start from here, 0 and 0. Yeah. Now we're gonna start to walk through this number 2, because we're gonna cut the trees according to increasing order, and all the trees are unique. Yeah. So this is what we are giving. All those numbers 2, 3, and 4 are unique. So this means we're gonna first cut over 2. So how many steps? 1, 2. So after 2 steps, so we're gonna cut off this 2. Now we need to cut off 3. How many steps we need to cut off 3? So it's gonna be 1, 2, 3 steps. So the minimum are gonna be 2 plus 3. Yeah. So from 2 to 3, it's gonna be 3 steps. So how many steps we need to cut over 4? So it's gonna be 1, 2, 2 steps. Yeah. So what's going to be the total steps? It's going to be 2 plus 3 plus 2. So it's going to be 7 steps. Yeah. So this is going to be the basic idea of how we're going to solve the problem. Yeah. But maybe here is another number. Let me make it, maybe we're going to have another number. Yeah, let me just use another color. Maybe we have another number. This is 7. So what's gonna happen? Yeah. So we're gonna still start from this 0, 0. We're gonna finish 2, 3, 4, and for the last step we're gonna plus 1. So the final result is gonna be 8. We still need to cut off this one. Yeah. We are starting from this one. This one can be empty or it can be some trees. So for example, here, this is a number 1, but this number can be a number 2 or some other numbers. It means yeah, we just need to cut the trees in increasing order. Yeah, let me just go back. So yeah, currently this number, maybe this number is 3. So what's gonna happen? So here, let me just make it this number. Maybe this number is 5. Yeah, so what are we gonna do to cut off all those trees? So we're gonna still start from 0 and 0. So we're gonna cut off this 2, so it's gonna be a 2. And we're gonna cut off, next we're gonna cut off 3. It means we're gonna go back. So from here, we're gonna go back. So it's gonna be 2 steps. And then we're gonna cut off 4. It needs 1 step. And then we're gonna cut off 5. It's gonna be 2 steps. So in total, it's gonna be 7 steps. So what is the idea to solve the problem? So basically, this is we need to sort all those numbers in increasing order. So basically, we need to put all those numbers in array. So what are those numbers? So basically, those numbers are gonna be like 2, 3, 4, and 5. Yeah. But for the first step, basically we need to start from the 0, 0 position. So basically we need to start from 0, 0 position to the position of this number 2. So what about the position of number 2? Basically it is 2, 0. And what about the position of this number 3? It's going to be 0, 0. Yeah. And similarly for this 4, it's going to be 0, 1. And for this position 5, it's going to be 1, 2. Yeah. So basically those are the positions sorted according to the height in increasing order. And we're going to use BFS to search from 0 to 0 to 0, 0, and how many steps, like from 3 to 2. Yeah. But for the first step, we need to give a position of 0 and 0. So this is going to be our starting point. So this means from 0, 0, it can go to 2, 0, and it can go to 0 to 0 as well. Yeah, so this is what we are doing. So this means while we are using the BFS, we need to so this means while we are using the BFS, we need to consider this 0 and 0. Yeah, it may be this 0, 0 to 2, 0, or maybe it is 0, 0 to 0, 0. So how many steps? It's going to be 0 in this case. Yeah, but for this example, it can be from 0, 0 to 2, and it can still go back to this 0, 0 position. Yeah. Now let's just try to solve the problem. Yeah. So the first step is that we're gonna try to find all those trees, and then we're gonna sort the trees in increasing order according to the height. This means we're gonna find all the positions, and then we're gonna use the BFS to get the total number of steps. If we cannot finish cutting all those trees, we're gonna return -1. If we can finish, we just need to count how many steps. So let's just do some preparations. So RC gonna be the length of the forest and the length of the forest 0. And let me just prepare directions. So inside tuple, it's gonna be 0, 1, 1, 0, -1, 0, and 0 and -1. So yeah, this is gonna be all the directions, and this gonna be how many rows and columns. Yeah. Now for the first step, we're gonna start writing BFS. So for this BFS, and basically it's gonna be starting from 2 positions to the target positions. So it's gonna be, yeah, let me just use RC to target. Let me just use this one. It's gonna be target R and target C. Yeah. So basically we're gonna start from this position to the target position just to check how many steps. So this is gonna be the BFS part. Yeah. Now we're gonna try to write our main algorithm first before writing the BFS. So BFS is gonna just return how many steps. Yeah, and we're gonna prepare steps later. Maybe I'm gonna give a steps of 0, but finally this BFS is gonna just return how many steps. for example, from like 3 to 4, 2 to 3. Yeah. Now, what are we gonna do? We just need to build an array. So let me just build an array as a trace. So basically, inside of the array, it's gonna be 3 variables. The first variable gonna be the height. So the height is gonna be the forest R and C. The second one gonna be the position R and C. Yeah. So for R in range with capital R, and for C in range with capital C, but we need to check the height of the tree. It's gonna be the forest RC. If forest RC is more than 1. Yeah. So basically, this means it's gonna be all the trees we need to cut. Yeah. Let me just print out what are gonna be the trees for the first example. Yeah. Let me just give a random return. Yeah. So in the first example, let's just check how many trees. It's gonna be like 2, 3, 4, 7, 6, 5. Yeah, this means it's gonna be okay. Yeah, we just need to get out a tuple, get the tuple, and then we're gonna sort it in increasing order. So let's just sort it. Yeah. So we're gonna sort it. Now what are we gonna do? So after sorting, basically we need to check the distance between this position to the next position. For example, 2 to 3. What's gonna be the distance? Yeah. But before that, we need to check the distance from this 0, 0 to 2. Yeah. Yeah, because currently we get 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7. That is okay. But what about 1 to 2? We didn't consider that. So this means for the tree, we still need to add the first position. So it's gonna be the trees gonna equal to the first position, which is gonna be 0, 0, and for the height, it doesn't matter. We just give a random 0. Yeah. So it's gonna be this one plus the trees. Yeah. Now let's just check what is inside. Yeah. Now as we can see, we're gonna got all those tuples. So this means everything should be okay. We're just starting from 0, 0 to 0, 1, from 1 to 2. Everything gonna be just included. Yeah. Now we're gonna just need to use we just need to use the BFS to solve it. So we're gonna use pairwise in Python. So for AB in pairwise with the trees, because this can avoid making so many mistakes. So what is AB? AB is just a pairwise of the trees. So it means each of the 2 points we're gonna get a pairwise. Yeah. So basically we're gonna prepare the final result. We're gonna set it as 0. So we're gonna check the BFS. If BFS not equal to -1, so we're gonna update it to the result. So the BFS gonna be let's just call the BFS. We're gonna use steps. Maybe here we're gonna call the BFS. So it's gonna be A1 and A2. And for the tuple B, we're gonna choose B1 and B2, because basically for the first position it doesn't matter. It is just the height of the tree. We just need to check the positions of the tree. So it's gonna be A1 and A2, B1 and B2. Yeah. So now we're gonna check the steps. So if the steps are not equal to -1, basically we need to update it to the result. Yeah. Otherwise, so we're gonna we're gonna return a -1. So this means basically it's not impossible. Yeah. So finally we're gonna return the final result. Yeah. So if it is possible, we're gonna update it to the result. If from any 2 positions that is not reachable, so basically it means we need to return a -1. It means we cannot cut off all the trees. Yeah. So currently what left behind is the BFS. We just need to finish the BFS. So now let's just try to finish the BFS part. Yeah. So how can we write the BFS? We need a weighted set and a queue. So let me first prepare the queue maybe. Yeah. So the queue gonna be the queue, and the inside gonna be the starting point of R and C. And the weighted set gonna be a set, and yeah, inside it's gonna be R and C as well. And we are going to calculate the steps. So I would like to put the steps just inside of the queue. So from the beginning, it's gonna be 0 steps. Yeah. Now finally, I'm gonna check how many steps. So now we just write BFS. So while queue, let's just use RC, and the steps gonna equal to q dot pop left. Yeah. Now we're gonna check the directions for dr dc. Inside the directions, we're gonna update the row and column. So it's gonna be r plus dr and c plus dc. Now what are we gonna do? We need to check the boundary first. Yeah. So this is gonna be the row boundary. Now we're gonna check the column boundary. So it's gonna be less than column C. Yeah. And we need a tuple of row and column. And row and column not inside. If if this is okay and row and column not inside the weighted set, and we need also to check the forest. So if there's no obstacles, basically it means forest row and column should be more than 0. If it is 0, it means the obstacles. If it is not 0, basically it is not obstacles. Even if it is 1, it means it is empty space we can go through. Yeah. So this means we just need to check 2 points, like from 2 to 3 if it is reachable, or 2 to 6 if it is reachable. We just need to check that. So if it is not 0, definitely it is reachable. Yeah. So if it is more than 0, so for the weighted set, I'm gonna add it inside, and for the queue, I need to append it inside. Yeah. So this is basically the BFS part. So for here, I need to check the row and column. So if R equal to target R, and C equal to target C. So this basically means I've already found my adding point. So I need to return these steps. Yeah, I think this is all about this kind of method to solve the problem. Firstly, we're gonna just take out all the trees, and we also need to record the positions, and then we're gonna sort the tree according to the height. And this is exactly according to the problem, because we need to cut the tree according to the height. After sorting, we just add the starting point with 0, 0 inside, and we're gonna use a pairwise. We just need to check the 2 points as a tuple, and the 2 points as a tuple 1 by 1 to check the final result. And we're gonna accumulate the steps if all of them are reachable. If it is not reachable, definitely we're gonna return a -1. But how can we check these steps equal or not equal to -1? Yeah. So from here, if it is okay, we're gonna return the steps. Otherwise, finally, we're gonna return a -1. Basically, this means it is not reachable. Yeah. I think now everything should be okay. But as I write so many lines of code, maybe there are gonna be mistakes. But it's okay. Let's just run it to check. Yeah, I did some mistake, because for the queue I forget to add the steps inside. Yeah, so I needed to update the steps. I'm gonna plus a 1. Yeah, now as you can see, it works. Now let me just submit it to check if I can pass for all testing cases. Yeah, now as you can see, it passed for all testing cases. Although the speed is slower, it is like 6 seconds, but it's okay. It is okay. You just need to compare with others. You just beat the 60% of all others. It means it is okay. And basically, this is a BFS algorithm. it's gonna be a little bit slower. Let's just check what is the m at n. M at n gonna be 50 and 50. Yeah. So for here, it's gonna be here we just use pairwise. Yeah, let's just check one by one. So for the trees, we just take out all those trees. So this currently here is gonna be mn, and we use a sort, so it's gonna be mn times log mn. But for here, it is okay. I think for here it is okay because mn is just 50. But what about here? So we will ignore these areas because basically here didn't take so much time. Now we're gonna check it from here. So for AB in pairwise, so basically for this tree, so yeah, so for this tree, the length of the trees is gonna be m times n, because we just take out all the trees. It means it's just these areas, maybe all of the areas are trees. We just need to cut off, so it's gonna be mn. So for this for loop, now we're gonna run the BFS. So what's gonna be the time complexity for one of the BFS? So for one of the BFS, basically it's going to be mn time. Yeah. Yeah, because for BFS, for example, this is the BFS. From this point to this point, what are we going to do? We might go through all the paths, so it's going to be mn time. So it's going to be mn squared, going to be the time complexity, and the space complexity going to be mn. Yeah. I think that's all about it. So for solving the BFS problem, definitely it is not so difficult, but we need to analyze what kind of method we're gonna use, and we have to be careful with our coding because there are so many lines of coding. Definitely, if you make a typo or some errors, some tiny errors, it's gonna make mistakes. Yeah, so we have to be careful with this kind of BFS. Thank you for watching. See you next time.